Hi guys, my name is Eze, and in this tutorial I'm going to show you how to create two types of Bitcoin wallets. We'll create a HD wallet and we'll create a legacy wallet. So I've already written the code that we can start with, so I will show you how to do it. So first of all, you would need to have Node.js installed. So if you don't have Node.js installed, you should go to nodejs.org and download the Node.js and download and install the Node.js for your operating system. So if you once you have that, we are going to use two packages. We'll use Bitcoin Core Live and Bitcore Mnemonic. So do me a favor and install it. Go to npm, go to the npm website and type Bitcore Live. You should see this. Just run npm install. Of course, I already have this installed, so there won't be any need for me to do that. So you should do copy and paste that and run install. Or since I already have it installed, it will just same thing, just update the package if there's an update. So basically that's it. We have that installed, but I am using yarn anyway, so I'm just going to delete this to avoid conflict. So if you're using yarn, you do yarn add. So you do yarn add Bitcore Live, and that will be it. Simple. But I already have it installed, so no, you can do that. So do for this as well. Copy this. I'm only copying this because I have it. So you just I'll share the link to it in the description. You just go to the npm and look for it. npm.out.com. So I'll search for Bitcoin Mnemonic. So the exact match is this. I'm just going to copy this. So this is it. So I'm going to show you how you should go check out the documentation, but I'm going to show you how to do this, how to create them in simple terms. So this is the documentation. You won't be able to access this documentation from here because I don't know, for some reason they added the wrong link. So if you want to access it, if you click on this, it will take you to a E404 page. So just click on this GitHub link, repository link. It should take you to the GitHub repository. So you can now see these places, these links. Click on the address link and it will take you to the appropriate address, to the appropriate link. So you can see that it's very simple and straightforward to create an address. This is to create a legacy address with this library. So we can copy this and paste it somewhere here, but there's no need to copy this. We already have this here. It's the same thing. It's the same thing we have here. So you can see that by default the library does not use to address does not have any network. That's because by default it uses the mainnet network, which is the LiveNet. So but we need to work with Testnet, so we are going to change this to Testnet. So as you can see, this is we are using a testnet because the network have been defined here. You could decide to type it with, you can decide to type testnet here like this, testnet, or use the one that is coming from the library itself. So I choose to use the one from to use the one from here. Okay, I want this to be modular, so I'm going to use this one, network. I'm going to use this network. So I'll allow the user to pass whichever network they want to pass for this application. So that's it. So when we are running this, we're going to see how to run this in a moment. So first of all, you can return the private key by doing private key dot to string, and that gives you the private key, and this also gives you the address as well. That's simple and straightforward, straight to the point. So this basically gives you an address that you can use. So we use the private key to sign, and we use the address to receive a token, to receive Bitcoin. So let's run it and see what we get. So quickly, I am going to. This is the code that should send our Bitcoin, but first of all, we need to create an address. So I'm just going to run this and create an address. So as you can see, I passed testnet to it. So you can see I imported the library and passed testnet because I want to use testnet. So let's go ahead and see what this gives to us. I will use this here, this terminal. So I'm just going to use this. So let's say we run this node. The application we need to run, the file we need to run is the app file, and it's inside the source src directory.app. So yeah, this gives us an address and a private key. So we can send tokens to this one and use it to do whatever we want. But this is a testnet address actually. So if we want a mainnet address, we can get a mainnet address as well. Just import mainnet from here and then use mainnet instead of testnet. You see that the address will be different. Sorry, I didn't save that file. So the address will be different. You can see that the address is different. So this is a legacy mainnet address. This is a mainnet address. Testnet addresses usually start with N and M sometimes. So that's that for our testnet address for the legacy address, for the legacy wallet. So this is ready to be used. We can actually test sending to this address from Bitcoin faucet. So we can look for one Bitcoin testnet faucet. So we can send funds to that address that we just generated. I've used this one like just now, so before this tutorial, so I'm not sure it's okay. They don't allow me to send again, so until 11 hours from now. So but I think I still have one from this website that I can use. I have like 0.1, so I'm just going to send to this address. Oops, they didn't allow me to send. Oh, the address I copied is not the testnet address anyway, so I'm going to, let's go back to the other one. So this is a testnet address, so we can send a testnet coin to it. So this website is a little slow, so it might take a while for it to send it. So but once it is done, we will be able to check it on Block Explorer. So I might, okay, it's done now. So this is it. Let's go to testnet Bitcoin testnet explorer. Let's check out. We can use this. Let's see if this shows up something. Okay, this doesn't show up anything, but I think, okay, it's asking us for a testnet, so I will just click on this. So yep, there is one transaction. It is still unconfirmed yet, so it could come later. So but for now, we have created an address and sent Bitcoin to that address. Next thing we need to do is we need to create a HD wallet. So before we create a HD wallet, let me get to the wallet and explain to you how it works. So this is the HD wallet, the Hierarchical Deterministic wallet. What this does is it's a new type of wallet, Bitcoin wallet, that allows you to generate several addresses from an XPub. So one private key can have several addresses, unlike this other, the legacy wallet that has one private key to one address to one private key. So but with this, we have a mnemonic, we have an XPub, and we also have, and we can, with this XPub, we can generate as many addresses as possible. every time this script is run, with the same private key, we can generate as many expub as possible. So yeah, and then I think that is it. But the major concern for HD wallet is that it's for privacy. You know, if you care about privacy so much, which is what Bitcoin is supposed to, which is what the blockchain is supposed to be doing, one of those core features of the blockchain is privacy. So if that is your concern, one thing you could do is you could use a HD wallet. A HD wallet allows you to generate those different addresses that you generate are independent on their own. Like you can use, if I send someone cannot use one of your addresses to know how the total money in your Bitcoin wallet. They can only see two transactions, the one that came into that address and the one that left. So you don't use that wallet twice. You only use it once. If you want, you can actually use it more than once, but it's advisable you use it only once, so that once there is funds inside that wallet, it comes and goes. Then nobody will be able to track your address. So, but if someone has access to your expub, they can't actually take money from your account, but they can see everything in your address. They can see all the money you have in your account. Okay, so that is it about the HD wallet. So this is how it works. First of all, you install this library, and then basically you initialize it, pass the language you want your address to, your mnemonic to generate, because humans are not usually good at generating mnemonic, so you want to automatically generate it. So you can use this to generate. There are several other languages. There's Chinese, there is Spanish, there is English. So you can, let's check the docs and actually verify this. So in the docs, let's see, I think we opened one of it here. Okay, so yeah, so this is it. Let's go straight to the docs so we can see how it looks. So it has been moved to here. Okay, good. So this is it. In the docs, it says you can use Spanish. Okay, there is not so much that you can see in the docs, but I think I can show you something. Let's try to inspect what is inside here. So I think I should open this a bit more and close this so we can see clearly. So I'm just going to open this, and so we can see in words, you can see that the words available here, we have English, we got Chinese, English, French, Italian, Japanese, Korean, and Spanish. So these are the languages you could actually use to generate your mnemonic. So that is it. Once you generate that passphrase, you can now use that passphrase to generate a private key, an extended private key. This is an extended private key. So you need to also pass the network here. You need to pass the network here as well. So yeah, basically by default, the network is mainnet, as just like the other one. By default, the network is mainnet, but you want to, if you want to use a testnet address, you can use the testnet address as well. So in this one, we are going to use testnet, but this is it. First of all, you create an extended private key. From your extended private key, you are now unlimited. You can create as many private keys and extended public keys as possible. So here we are able to create an expub. This is an expub. This is the expub that will allow us to generate as many addresses as possible. And then this is the private key. We can use our extended private key to generate a private key that we'll use that we can use right now. And then next is the address. We generate the address with this that we can also use as well for this transaction, and then the passphrase as well. So you can retrieve your account, your wallet, with either the passphrase or the private key, and you'll be able to send funds also with those two as well as you desire. So that is it about that. we are going to also, let's try it out. Let's see how it works quickly. So instead of using the create wallet, we're going to use create HD wallet. You can see that we exported it. So I'm going to expand this a bit so we can see the, okay, no, I need to open the app, and then let's use create HD wallet instead. Create HD wallet, and then we'll pass mainnet to it. Okay, let's pass testnet first, because we basically want to create a testnet address. And then once that is done, let's run the script. Yep, we have testnet address generated for us with everything we need: the expub, the private key, and the address. This is like the base address that we can use, and then this is the mnemonic. So we can use all of this. We can also send funds to this address as well. So this is it about creating an address. I'm going to leave a link below to see all of this code and how it works, and also share my article on LogRocket to you as well, so you can read more on this. But this is basically how you can create an address and use them. So now that we have an address, let's see how to send Bitcoin. So if you followed through to this point, congratulations. I'm glad you're following through. You get to this point. So now next thing is, let's see about sending Bitcoin. So I'm going to, now that we're done with this, I'm going to comment this and then bring this to life. So this is it. Let's explore how this is going to work first. So this is send Bitcoin. We have a function that sends Bitcoin. So we imported it from this. Before I get to walking you through that, let's see. So I want to send funds to this Bitcoin address. So I just passed it here, and then this is the amount of Bitcoin I want to send. So let's run it and see if it works. Oh. What? Okay, sorry, I didn't uncomment. I didn't save save it when I commented it. So now we are going to send Bitcoin. So good. We are done with sending the Bitcoin. We are able to, our transaction ID is this. We've sent 0.0001 Bitcoin to this address. Let's confirm this on the blockchain. So I'll pass so this is a transaction. Remember, we sent 0.0001 Bitcoin to this, and that is it. But it's still unconfirmed yet. Still unconfirmed. So that is it. So I'm just going to show you how we did that now. Let me open. You can see this. So I'm just going straight to the code, and then I'll close this so that we can have a full screen for this. All right. So here we go. So with this, we're going to use the Bitcore lib to run this. So just create a function that receives the address and the amount we want to send. That's it basically. We use the try catch block so we can catch errors when they happen. And then we are going to be using Sochain network. Sochain is a blockchain explorer, and they allow you to do a lot of things for free. So we are going to use them to Sochain. So we're going to use Sochain's API. So they do a lot of stuff. So we are happy that they allow us to use the API for free. But just know that the API is metered, it's rate limited. So you want to use it within this limit. So that is it. We are going to use that Sochain for the two things we are going to use Sochain for are picking the inputs picking the input that we need for our Bitcoin transaction, and also broadcasting the transaction to the blockchain. Those are the two reasons we need Sochain. So we're going to use Sochain for that. You can check the Sochain API for more information on how to use it. But in this one, we want to get transaction data, right? We want to get transaction data, so we want to get the unspent data, unspent input. So that's what we are going to use basically. We want to get the unspent input from Sochain for an address. So we're going to use that for that. And then these are some of the things I generated this private key from that script we wrote earlier. And then this is the address. So with in a Bitcoin transaction, for you to be able to send a transaction, you send from an address. Even though your private key is able to sign transactions, you need to send from an address that has funds. So this address has the funds. I've sent some funds to this address, so we have funds in this address I want to send. So with that being said, we have the private key, which is going to sign the transaction. We have the amount. So you can see that we are multiplying this by 100 million. This is 100 million. So we are multiplying this by 100 million because one Bitcoin is equals to 100 million Satoshis. So for us to be able to allow users to type that the amount as it is, most explorers need you to convert all your transactions to Satoshis because they do the calculations in Satoshis. So we are going to do that. So the amount we want to send is 0.001. So we multiply that by 100 million, and then it gives us something. So whatever it is the amount that we're going to send to the blockchain. So the fee, we initialize the fee at 0. You will see more on that later in the course of this tutorial. You also see the input count and the output count. So the input count are the total amount of transactions, total number of unspent transactions in that address. So you can see, let me show you how this works. So this is an address. I'm going to use the browser to show you this. So I'll replace this with an address that has funds. Then the network. For Sochain network, we're going to use BTC test. BTC test. So this returns a transaction. So it returned one transaction. This is the transaction ID. And it returns the value. So in this address, we have just one transaction, one unspent transaction. So if so many transactions came into this address, they'll be added to this array as transactions. But right here we have just one transaction inside this address. So this is basically that output, the leftover money that was in that transaction we just made before I started explaining to you. So there were several transactions that were compiled to form this one transaction. So in this address, we have one transaction for now. So our input for here now is going to be just one, eventually to be one, but we're going to do that dynamically so that our script will always work regardless of what we enter as the input. So these are the inputs, the number of unspent transactions in this address. So we have that one input. So the output count will always be 0. In the Bitcoin transaction, there will always be 2 outputs, because the first output will go to, except you're making multiple transactions, you're making a bulk transaction at once. Otherwise, your output will always be 2. So this is it. If you're going to send a Bitcoin transaction, you send one to an address, the receiver's address, and then you send a change back to yourself, back to your own address. So in a Bitcoin transaction, all the funds in your address are being spent. You spend all of them at once. So you can either send the remaining, if you send one transaction, you can either send back the balance, which is called change, to your own address, or you can send it to the miners if you're very, very, if that's what you want to do. Actually, you can send it to the miners, or you can send it to anyone. So that is up to you. So those transactions you just did are output. Those are output. So those is definitely going to be 2 outputs. That is going out of your account. But if you're going to make a bulk transaction, well, that will change. You won't have to hard code it as 2. So you will have to calculate it. So if you're going to send to multiple persons at once, then you know that you have to calculate those multiple persons and add it as the output. So that is what we are going to use for the output. So next thing is this response. This is where we are going to automatically check for any address that was passed, the source address. So this is our source address. The source address is going to be our address, the address that has our funds that we want to send, and then the network. So this is BTC test that we're going to use. And then next is the transaction fees, recommended fee. So there is a transaction fee which is based on the network, a lot of variables around the network. So there is a fee. This Bitcoin fees website gives you a recommended fee, so we are going to be using that fee for now. So you can go to this website to see. I'll just show you. I don't want to show you the API. Okay, the API should return something, but without using the API, we can also see what it shows. This is the fee in Satoshis per byte that people are using. So you can see that different persons are using different fees and with different delay. So if you use this amount of fee, it's estimated that your account, your transaction will be executed within this time, within this period. So this is in time and this is the delay. So you just check this. But with the API, the API gives us a summary, more like an average of what people are using. So if you use this hour fee, means there's a likelihood that your transaction will be able to be executed within an hour. You get? So if you do this half an hour, 30 minutes, fastest fee. So this also is going to cost you more. Okay, so that is how the recommended fee works. I want it to be automatic so that we always have the perfect fee structure and our transaction doesn't get hooked up. Okay, good. Now that we understand how the fee structure works, next thing is how are we going to get through this part. So first thing first, we're going to initialize the Bitcoin transaction. We're going to use this construct, initialize the transaction class, and then that'll be it. Then we want to have an initialized total amount available in your account so that we can always add to it. From our loop here, we're going to do that. So initialize the input as well so that we can store all the input data, because the reason we need to do this is because the way the transactions are coming from Sochain is not the way Bitcoin Core expects it. So we need to adjust and build our own input the way Bitcoin wants it. So that's why we are doing this. So we take all the transactions and then try to build our own our inputs from it. As you can see, we initialize the UTXO, and then UTXO is actually on spent transactions. So that's it. We are going to we are going to do that. Just do satoshis. These are all the variables, all the keys that the this thing is looking for. So at the same time, we also add the total amount available to this, and then it gives us the total amount that we have in our wallet. So we can use it whenever we want to. So we also push all the UTXOs that we've created. We've created one UTXO, build one UTXO, we push it to the input. So that will give us the total input, the total stuff that we have. Right here, we will have a valid input. We can also call this input the clean UTXO if you want to. That's also a good way to call it. The next thing is we need to calculate the transaction size. In Bitcoin, you can read what I wrote here. In a Bitcoin transaction, the inputs contribute 180 bytes each to a transaction, while the output contributes 34 bytes each to the transaction. Then there is an extra 10 bytes you can add or subtract from the transaction as well. So this is basic in all Bitcoin, in all legacy Bitcoin transaction. This is the transaction we are sending as a legacy transaction. There is SegWit, there is other forms of making this transaction. So but for this one, we are using the legacy approach. So let's get to the next. So the transaction size is based on that. So we're going to multiply the input by 180 and then add it to the output count. How many? We've already set this to like 2, right? This is the output, and then the output count is the total of our input from here. So we did make the output count from here so that we don't have to do it again. Another way to do that is to do input length. Input length should also give you the input count. So we multiply it by 34, add it by 10, and then subtract it by the input count. So basically, that is how we get the transaction size. So we use the transaction size to get our fee, to kind of estimate our fee. So the fee we need to use is to get this, we multiply the transaction size by the recommended fee. So you can see that we are doing this. Okay, sorry, I'm dividing this by 3. Actually, you don't have to do that. You don't have to divide it by 3. I actually felt like it was too much, more like the fee was too much, so I decided to divide it by 3 so that I get a fair share. So you can actually do that as you want. So, but for me, that is what I choose to do at that time, because I'll just test and I didn't want to spend so much on fees. But you can send this as well if you want. So that's basically it. So we can do 3, that we don't spend everything at once. So that's it. And then you can do your checks. Make sure the user is sending as much money, more than they have enough sufficient fund to including the fees to send the amount they want to send. So you can see that we are checking that the fee is actually what it should be, and then that's it. That gives us the amount we want to get, and then if it is not, that transaction should not go through, and then we pass the input to transaction.from. This is basically a concept from the Bitcoin lib, and then you pass the address you want to send to, and then the amount you want to send as well. Just know that this amount, we multiplied that amount by the amount the user entered, say 0.001, we multiply by 100 million. So this is what we are sending, the amount that comes out of that 100 million. So that's basically it. We pass that and send, and then we initialize the change address, which is our source address, our own address. We send it back to ourselves. So I hope you understand that. If you don't, you can put any address you want here, but since I want the address to be my own address, I want to get the money back, so I put my own source address. So that's basically it. You can take this off. If you want to console log to check, you can do that as well. So you can, if your fee shouldn't be running into decimals. Your fee shouldn't be running into decimals. It should be a whole number. So that's why I'm rounding this up. I'm rounding this up because I'm dividing this by 3. So this is going to impact what the result that is going to come out from it. So I have this to make sure that the value is a whole number. It doesn't have a decimal. So you pass the private key to sign it, sign the transaction, and then serialize the transaction, and that's it. Now, once you're done with this part, the next thing you need to do is to broadcast the transaction. So this is when you send the transaction to the blockchain. So you just initialize this. You can use whatever you like to use. I'm using Axios. You can use node fetch. You can use fetch, whatever works for you. Whatever works for you. You can use request, whatever works for you at this point. Just make sure you're sending this to the chain at the time. So this is it, and this should return you the transaction, if it was successful, or if it was successful, you will see the transaction ID, and then you will be able to use that for whatever you want to do. Then if it's not, you get an error. So that's basically it for sending Bitcoin using this. I will also give you this script. I will send this script in the description so you can use it as well. The thing about this is that you can basically set up a small your own personal wallet in case you don't want to use an exchange. You want to keep things private to yourself offline. You can do this and it works perfectly. So just know that each time you want to send, you want to use a live address to send, you have to change this to BTC instead of BTC test. If you're going to use Sochain. So if you're not going to use Sochain, you have your own node. You have a full node for yourself. You hosted a full node. You can use your own node as well. There are documentations and places you can get Bitcoin. You can install Bitcoin full node for yourself. If you make a search, you'll find that Bitcoin full node. If you go to, this is it. You should be able to see documentation on how to run a full node. So that's it. That is it. The important thing to note here is this is one library that will be like a lifesaver for you. Go to the documentation, you find a lot of information that I haven't covered here. You find a whole lot. Then you can and definitely read up about Bitcoin and learn more about Bitcoin transaction and how it works beyond you just using a library to get something working. You should dig more into how these things actually work. But for now, this is it. You have a Bitcoin transactions. You've been able to create a Bitcoin wallet for both legacy wallet and a HD wallet that you can use to generate and send you can use to receive and send Bitcoins. So basically, that's it. We are going to send one more Bitcoin to myself just to mark the end of this tutorial. So let's send another one. Hopefully we don't get an error. So this is it again. There we go. Our transaction was successful. So we check this again and then go to an explorer. Make sure you're using a Testnet Explorer. Testnet Explorer. Yeah, that's taking a lot of time. So you can put this here. So that's it. Our transaction went through 0.01 Bitcoin. Another thing you can do is that you can, I copied, initially I showed you this, right? I console logged this, the serialized transaction that have been signed. This is a signed transaction. If you copy this, you can actually use block cipher if you want to manually do it. In case you don't have access to Sochain, or maybe Sochain stopped working or something, but you're able to somehow get your UTX, make those calculations, and then you get this. You can also use block cipher to publish your transaction, to broadcast your transaction to the blockchain. As you can see, push raw Bitcoin testnet. So you can push it here. But since we've already done it, this transaction will not, this shouldn't work. Error, transaction with hash already exists. So you can see that this already exists, so we can't do that. So that is it. That is it. That brings us to the end of this tutorial. Thank you so much for watching. If you like what you just watched, like, subscribe, and share with your friends. So I'll be coming up with some other videos on how to sign with Ethereum and Solana. So thank you so much for watching. I hope you learned something from it. So I will drop links to this, to the GitHub repo, where I am going to put this. I'm going to show you the log record article, and I'm also going to send some links for you, so to make it easy for you to navigate through this whole process. Thank you so much. Have a good day. Bye.